Hey guys, it's Malta here, and in today's video we are going to finish learning how to evaluate limits analytically. Specifically, we're going to use a couple of special trigonometric limits to help break down a limit involving a trigonometric function to the point that it can be evaluated through direct substitution. So without any further ado, let's get into some examples. So, actually before we begin, I want to point out these special trigonometric limits, because these two limits that I'm going to display are really the basis of how we are going to solve these upcoming problems. So the first trigonometric or special trigonometric limit that we have is the limit as x goes to 0 of sine of x over x is equal to 1. So this is our first real sort of identity, if you recall from Algebra 2 when we had trigonometric identities. And then really our second identity is we have the limit as x goes to 0 of 1 minus cosine of x over x is equal to 0. And so these two limits are going to be really the basis of how we go about solving the rest of these problems that we bring up. And so we're going to use these repeatedly. So the first question that we're being asked to evaluate is question 63. And in 63, we're looking at the limit as x goes to 0 of sine of x all over 5x. And so right away you can see that there is some tie-ins from this problem to this first trigonometric limit that we had. And so what we can do is we can take this trigonometric function here, and we can say the limit as x goes to 0 is really just 1/5 times sine of x all over x. And this makes our life a ton easier, because from here we can say that the limit as x goes to 0 is just 1/5 times 1. Because this sine of x over x, we have proven when we have a limit that goes to 0 that it goes to 1. So we end up with 1/5 times 1, which gives us a final result of 1/5. So there we go. Then we have problem 65. And so in 65, we're being asked to find the limit as x goes to 0 of the function sine times sine of x times 1 minus cosine of x. And this is all going to be over x squared. Now, in this sort of problem, we're going to have to do a pretty similar technique as we've done previously, but we're going to continue using these functions, these trigonometric special limits nonetheless. So our first step here is we're going to say we have the limit as x goes to 0 of, we can change how this is written by saying this is really just sine of x over x times 1 minus cosine of x over x. And so now what we've done is we've essentially just broken this, I guess, multi-dimensional fraction into its really individual parts that we have here. And so now we can easily use these, I guess, special trigonometric limits that we've developed in order to solve this. And so sine of x over x, so the limit of x going to 0, is just going to give us a value of 1. And then the other half, this 1 minus cosine of x all over x, this is going to give us a value of 0. Multiply these together, we get 0 as our final result. So there we go. Now in 67, we're being asked to find the limit as x goes to 0 of sine squared of x all over x. And so our first step in this problem is we're going to say that this is really the limit as x goes to 0 of sine of x times sine of x all over x. So all that we've done here is we've basically just removed one of these sine x components from the numerator, and so now we just have sine x times sine x over x. And so from here what we can do is, it's pretty straightforward, because now we're back to our basic identity. So this now becomes the limit as x goes to 0 of sine of x times 1, which just results in the limit as x goes to 0 of sine of x. And if we make sine x go to 0, as we do so here, we're just going to end up with a value of 0 once again. So as you can see, in most of these problems, in all of these problems actually, we're using these basic fundamentals that we've developed, these basic fundamental, special trigonometric limits. So then for problem number 69 here, we're being asked the limit as x goes to, as h goes to 0 of 1 minus the cosine of h squared all over h. And so the way we're going to do this problem is we're going to do a very similar technique as we did last time. And so we're going to basically say that we have the limit as h goes to 0 of 1 minus cosine of h times 1 minus cosine of h over h. And so now, once again, we can use the limit that we developed previously in order to say that this is really the limit as h goes to 0 of 1 minus cosine of h times 0, which, because we're multiplying by 0, no matter what this value is, we're going to end up with the final result of 0. So there we go. So now we got 71 that we have to do. And in problem number 71, we're asked for the limit as x goes to pi over 2 of cosine of x over cotangent of x. And one thing we want to realize before we get into this problem is that the cotangent of x is equal to cosine of x over sine of x. And so you'll see how knowing this really basic identity is going to be important in, solving this problem. So what we're going to do is we're going to say the limit as x goes to pi over 2 is cosine of x over cosine of x over sine of x. And now what we're going to do is, because this is a complex fraction, we're going to try and make it a normal fraction. So we're going to do this cosine, we're going to do this in a sense. We're going to take this cosine of x over 1 times, then we're going to flip the cosine of x and sine of x into sine of x over cosine of x. And what we're going to see here is that these cosine of x cancels. So we're just left with the limit as x goes to pi over 2 of sine of x. And so this comes sine of pi over 2, which, as we know, is just going to be equal to 1. So there we go. That's our answer for this one. Now, we have 3 more left to do. And so we have, if I scroll the page here real quick, oops, that was a little much. We have 73. And so in 73, so in 73, we have the limit as t goes to 0 of sine of 3t over 2t. And so in this situation, we're going to have to employ a bit of a different strategy in order to solve this one. So we're going to have the limit as t goes to 0, and what we're going to do is we're going to say sine of 3t over 2t, and we're going to multiply both the numerator and the denominator by 3 over 3. And so what this is going to do is this is going to transform the problem into the limit as t goes to 0 of 3 times, I should have said sine, not sim, 3 times sine of 3t over 3 times 2t. And then what we're going to do is, so the limit as t goes to 0 is going to be 3 times the sine of 3t over, and then, because multiplication we can interchange these variables, we're going to make this 2 times 3t. So we're going to end up with the limit as t goes to 0 is going to be 3 halves times the sine of 3t over 3t. which should look a bit familiar to how we solved our problems previously. And so to our, I guess, special trigonometric limit that we have used previously. So now what we'll do is we'll put this 3/2 out front, get the limit as t goes to 0, and we'll get the sine of 3t over 3t, which is going to reduce down to 1, so we're just going to end up with a result of 3/2. So there we go. So now we have 79 and 81 left to solve, and so in 79 we have the limit as t goes to 0 of the sine of 3t over t. And so now what we're going to do is we're going to say the limit as t goes to 0 is the sine of 3t over 3 over t, and we're going to multiply this by 3 over 3, like so, and we're going to get this is really the limit as t goes to 0 of 3 times the sine of 3t over 3 times t, which is just really 3t. So then what we can do is we can say this is the limit as t goes to 0 of 3, and we can make it sine of 3t over 3t. This is going to reduce down to 1, so we get a final result of just 3. So there we go. And now for our last problem, which is 81. In 81, we're being asked for the limit as x goes to 0 of the sine of x squared all over x. And so in this problem what we're going to do is we're going to say the limit as x goes to 0 of sine of x squared all over x. And so what we're going to do is we're going to multiply, in this case, we're going to multiply x over x, like so. And we're going to end up getting this is the limit as x goes to 0 of x sine of x squared all over x squared. And so now what we'll do is we'll take out this x here, and so we'll get the limit as x goes to 0 of x times sine of x squared all over x squared. And then this is going to end up reducing down to 1, so we're just going to get the limit as x goes to 0 of x, which will result in a value of 0. So there we go. That's pretty much how we go about solving these types of problems. And so hopefully this was helpful. And yeah, well, thanks for watching. If you liked the video, give it a like, and if you want to receive more content, I definitely suggest subscribing. So thanks for watching.